Hey, hello everyone. This is Sumit here.
Yeah, hi Sumit.
Hello Gaurav, how are you?
Hi Sumit, sir. How are you?
Good, good. Hey,
Everyone.
Vaibhav, I'm good, I'm good.
Hello. Okay.
I hope I'm audible quite clearly.
Yes, you are audible clearly.
Thank you. Okay, Gaurav, let me know when are we starting.
Yes,
Hello,
Sumit.
everyone. This is Seth.
Hey, Sid, how are you?
I'm doing great, sir. Nice to be in touch with you. So glad to hear your voice.
Thank you. Where are you from?
I'm from Czech Republic,
Oh,
Central Europe.
yeah. I'm just trying to remember if I have any friend in Czech Republic.
Mhm. Okay. Close to Germany, close to Poland,
I do have a friend of mine who is in Slovakia.
Slovakia. Oh, okay. So close to us, actually.
Yeah.
I go there from time to time. I have a couple of friends there as well.
No visa required?
No, the visa covers all the European countries, so we have access to all the countries around.
Nice. I'm going to start sharing my screen in a moment. Just let me know if you can see the screen. Is this good? Screen is visible?
I can't see. I can see your screen, but it's all blank.
Yeah.
Yeah.
You haven't
Should
write
be good
anything,
now.
right?
Is this
Okay.
good now?
Yeah, VLAN, sir.
Yes,
I got
sir.
it. So
Okay.
today, so this class is gonna be for CCNP and core, right? Weekend
It
class.
is going to be for CCNP and core.
Weekends class.
Weekends.
Okay, great. So today, just for like every does teaches kind of intro, right?
It is going to be the intro, but we will be covering up a technical aspect, which is going to be VLANs, access ports, trunk ports. What are the differences? What are
Okay.
the different type of VLANs we have? A small lab, I would say, and should be good for 1 hour, I guess.
Okay, so basically, how many hours you do? Weekends, like 2 hours or like one hour?
No, for weekends, if we go for 1 hour, it will stretch for a very long time. So somewhere around 1.5, I would say. And depending on topic, may go to 2 hours, 45 minutes.
Okay, cool. Yeah. Thank you, sir.
Hey, Gaurav, we are good to start.
Yeah, Sumit, we can.
Thank you. So, hello, everyone. My name is Sumit, and I'm going to be your instructor for this course of CCNP and Core. Brief introduction about me. I am having 12 years experience, to be precise, 11 years and 6 months into the networks, where I have worked with different domains, which includes NOC implementation, TAC. I've not worked much on the design part, but I do have a certain number of experience into the designing of the networks. Where I'm currently working is one of the top financial institutions across the globe, and this is what I'm doing, as it's good to provide or it's good to share what you ideally know. So you don't need to call me sir. Taking a name would be a good habit for everyone here. At least with Asian countries, this is more of a habit as compared to Europe and US. So starting off with, and before that, yeah, one thing where I have worked with service providers. I do have experience to work with manufacturing plants. I have an experience to work with banks and multiple enterprise companies. Now, the topic what we are going to talk today is moreover about very basic and which I believe is very much needed, as I've seen the importance of it, that what we will experience it throughout our CCNP and core syllabus, as well as through your professional experience journey. Very basic topic, I would say, but still important. So first, as you can see on the screen, VLANs. In simple words, or if I talk about the full form, it is virtual LAN identifiers. Anyone, can you tell me what is VLAN? In very simple words, what exactly is a VLAN in one line?
Sir, VLANs we used to, create in a switches, for example, sales, marketings, for the security wise, so they don't talk each other.
Okay. Anything else? Any other simplest form of definition if I ask what is VLAN?
It's used to separate broadcast domains.
Yeah. So in simple words, logical separation of broadcast domains. Correct? In very simple word. But to understand more about this, we need to understand first what is a broadcast domain. If I ask you, anyone knows what is a broadcast domain?
Yes.
Cool. In simple words, broadcast domain is, let's say this is a building. And we have a PA system. Do you know what is PA system? Maybe public address system, where you have speakers installed on every floor. And whenever you speak through the mic of this PA system, it will be audible to everyone. Correct? This is one simple broadcast domain. If I talk it in non-network language, where if you talk, multiple people can hear you.
Yes.
Now, in networks world, if you remember, before even the switches were introduced, we had this concept called hubs. What was the job of a hub? Let's say this is my hub, and I have 4 machines connected to them: PC1, PC2, PC3, and PC4. So let's say if PC1 is trying to send some data, it would be received by the hub. And what hub would do in this case is it would forward it everywhere. Because hub is having a one broadcast
channel
domain, correct?
Yeah.
Now,
Yes.
with respect to switch, even if you replace the hub with a switch, the behavior is same. That we have one single broadcast domain by default. If PC1 is trying to send some data, it would be forwarded towards PC2, PC3, PC4, which will eventually create unnecessary flooding of the frames, correct? So in simple words, the broadcast domain is nothing but whenever a frame or a packet is broadcasted by one end machine, which in this case would be PC1, it is sent out of the every port of the switch except from where it has received it. So if I just clean this up, this is my switch connected to one PC, second, third, fourth. So in simple words, any data received, any data sent from PC1 would be received on switch 1 and switch on the switch, and it will forward it towards another ports, except from where it has received it. Okay. Now, what is the problem with having one single broadcast domain?
Collisions.
Lot of collision, lot of broadcast of the frames whenever it is not required. So let's say PC1 wants to send the data to PC3, but PC2 as well as PC4 will also have to hear it, though it is not required. They are not interested to listen to what PC1 is saying. But still, because we don't have any kind of segregation at this moment, it is being received by all. And this is where the VLANs will help. What VLANs will do? VLANs will logically separate out the interfaces. These 4 interfaces be separated out. This is how the broadcast domain problem is being solved by the VLAN. So what ideally we do is, let's say PC2 and PC4 are part of same group what you have defined in the company. Maybe they are part of HR. And PC3 and PC1 is a part of maybe research. And there is no need that HR and research needs to talk to each other. So what you will do is, you will do a logical separation of research and HR. And that will be done with the help of VLAN. Okay, clear till now?
Yes.
Yes.
Perfect. Now, what exactly is a VLAN? Is it an integer? Is it a string? Is it some kind of numbers? Or maybe alphabets? Or maybe some special characters? What exactly is a VLAN?
Numbers.
So VLANs are nothing but numbers. Let me clean this up. Anyone wants to pick up anything from this? Any notes? Good. Moving forward. So
Before you
VLANs
start,
are not.
can I ask you one thing?
Go on.
So, I mean, like, without creating a VLAN, is there any way we can, do like a separate, to like sales or marketing, don't talk each other? Is it without creating any VLANs?
You
Because
can
I
do
have
it at
like a-
layer 3. You can do it at layer 3, where you can put IP address on every single interface of the switch. So you define this as one network domain. You define this as one network domain. You can define this as one network domain, and you can define this as one network domain.
So IP we have to be configured in a switch, right?
Yeah. So this is the logical separation, what you can do at layer 2 of the OSI as well as layer 3 of the OSI.
Okay, layer 2 and 3.
Yeah, I hope you remember about OSI reference model.
Data
We
and
have
network.
data and network. So all we
Yeah.
are talking about is, today we are only talking about which layer?
Layer
Physical.
Data link.
Data link. So
Okay.
VLANs ideally would work at what layer?
layer 2.
Data link layer.
Because you are creating
Layer
them
2 and
on
3.
switches, correct?
Layer 2 and 3.
3, we are not
Network.
talking about SVIs. We are not talking about switch virtual interfaces. We are plainly talking about just VLANs. So only plain VLAN would work at data link layer. Now, VLAN is nothing but a number. Is a number. So if it is a number, for sure it cannot be infinite. There would be some value, correct? What is a
Yes.
value? What is a maximum value, or what is a range in between you can create a VLANs?
0 to 4095.
Total numbers
4094.
are 4096.
4096. Yeah.
These are total values. How this has been determined?
From 0 to
Ethernet
4095.
headers are mostly of 12 bits.
No, let me tell you something interesting. You know, our machines only understand two things. One
0
and
and 1.
right?
Binary.
Binary. Now, why they decided that they would only go with 4096 as maximum? Why not higher than that? What is the story behind it? Anyone have any clue? It is related to Ethernet frame. We are
128.
talking about Ethernet frames, but someone said about 12 bits.
Yes.
So
Yes.
12
So VLAN
bits.
only support 12 bits of the numbers.
Yes, VLAN only
hexadecimal numbers.
supports 12 bits. So ideally, whenever you do 2 raised to 12, it would give you
4096.
4096.
4096. Yes.
Okay. Now, moving further, this is what we have spoken about VLAN as a numbers. Any other use cases of VLANs? I hope I have not gone to the introduction part today. I don't want it to. Probably next week when we will be going full-fledged, I'll be talking to you guys more to find out what exactly you are doing with your current job, whether you're studying, so that we can bring the best out of everyone. So what are the usages of VLANs?
Segregate
One we
the
already
traffic.
saw, segregation. Second is reducing
Bandwidth.
broadcast.
Broadcast. Okay, sorry.
Top.
Anything else? You can introduce some kind of security into it.
Security.
Yeah.
Some kind, some kind of filterings you can bring on the VLANs level also, or at SVI level, or going further. But this is basically the segregation what we ideally do. Now we are speaking about 4096, correct? Tell me most important thing or another interesting thing in computers world. Numbering starts from 0 or 1?
0.
0. So what is the maximum value you can configure on from VLAN perspective? So total is 4096.
4096.
This is confusing.
2048.
Sorry, it's 4095.
4095.
Yeah, 4095.
4095.
Why? Because you are starting from
0.
0. So 4095 plus, if you remember, if you
0.
consider this as one value, the total goes to 4096. Correct? Now, some further details with respect to how these numbers have been segregated. There are some reserved VLANs, there are some default VLANs, and then something we called as extended VLANs and all those. But should I clean this up first?
Yes.
Yes.
Okay. Now, so let's say 0. This is a part of reserved VLAN. You cannot do anything with reserved VLAN. So 0 is a reserved VLAN. 4095 is the reserve VLAN. So if you remember, we started from 0 and we went till 4095. So this is reserved. This is
Reserved
reserved.
for switch, sir?
Not for switch. Ideally, they have not used some of the values considering there would be multiple probabilities. One, you can say that from futuristic approach, which ideally I have not seen any of the futuristic approach being implemented, at least for VLANs. So I have not gone to the depth why these were reserved. What was the motive behind this that they would reserved? In simple words. So one you can say as a future. Another would be maybe internal usage on the switches. Internal usage can have hardware related behaviors. It can have internal communications. But I have not read any of the documents on any platforms which really speaks about any of the reserve VLANs being used from for internal communications, at least with plain catalyst switches or plain switches what we are using. There would be exceptions to these for sure. And then some more reserve VLANs are 1002 to 1005. Anyone knows what are these 1002 to 1005?
Talking ring.
Yeah, all the, I would say, outdated technologies. One is token ring.
Token rings, yes.
Then I believe another one was FDDI, which I've not seen like 10, 11 years. I've not heard anyone using this. There would be systems which may still be using these specific technologies. And two, there are more. Let me find out those. VLANs 1002 to 1005. I've never paid attention to this, to be honest, because it is of no use to me. So our focus is going to be moreover on the use cases or the practical cases. So FDDI default, token ring default, FDDI net, and TR net. To add up for more here, FDDI have two reserve VLANs, one for token ring, and one is a TR net. Now, what is the range we are talking about? Another is standard, where it would be 1 to 1001 VLANs, and then there would be extended, which would start from 1006 to
4095.
No one is going to ask you all of these things in details, just that you should know. Okay, all good till now?
Yeah.
Perfect. A quick lab, what we will do is just to create the VLANs. I know many of you guys must have done CCNA and you guys are already aware about creating the VLANs, all these aspects, just that because we have to build that sync between us, between me and you guys, that is the reason we'll be going from scratch. This is going to be our topology, the basic topology, which you can practice later on. I'll try to introduce some faults into this to find out what could be the possible problem with VLANs, access, trunk, and all those behaviors. So first, we'll go to switch 1. Give me a moment. Let me log out and log in again.
How do I access with this lab?
Gaurav will be providing you those details. Don't worry about that.
Okay.
Give me one moment. Am I doing something wrong with password? Just one moment. Let me grab my password. Just 1 second. Okay, I was doing it wrong. It is. Okay, we always start from basics. Always first thing,
Configure terminal.
yeah, and then I always prefer to give the host names to the
Host name.
switches so that we have this habit. Even if you are preparing for CCI, this will help you to increase the speed as well as it will help you to understand how exactly you're setting up the topology. It gets fitted into your mind. Now, maybe I'll create two VLANs here. How to create the VLAN? If you just put VLAN and then number, maybe 10, and whatever name you want to give it, maybe HR. And second VLAN, 20, maybe I would give it name as RNT. So this is a base on how to create a VLAN. There are multiple ways to create the VLANs. One is via dynamic option. There are two options to ideally create the VLANs. One is via dynamic method. No one is using it. This is done by a VMPS servers.
VMPS.
And then second one is a static method,
Static.
which we just did via CLI on switches. So what we just did was to create the VLANs on one switch, and I will have to follow the same thing on other two.
What about the web portal, like HP web portal?
HP web portal would be another thing which I have never explored. You're talking
Okay.
about configuring the VLANs?
Yes, yes, yes.
Very much possible. See, multiple vendors will bring their own support systems because they are considering it as a product to sell,
Okay.
right?
Okay.
Now, the VLAN numbers are most important. Names can be anything. Even if on my primary switch, I have kept the name here as a HR. On my second switch, maybe I can give the name as HR1 because names are never traversed across the two switches. They will never traverse from switch 1 to switch 2. Doesn't matter what name you are configuring. Ideally, it is good to have a same name to maintain the symmetry so that you would be quite clear what is the purpose of having this VLAN on a specific switch. Maybe VLAN 20, and it would be same thing. What I'm going to do is for third. And here I forgot to configure the host name. Switch 3. Always have the habit to save the configs. So I started my CCI preparation in 2012 and I attempted it in 2013. No, I started it in 13 and I attempted it in 14. And from that time, I have got this habit of saving the configurations. It may not be every time useful from a production or where you're currently working. The scenarios may not work, but with respect to exams or labs, CCI lab to be precise, it really helps. Now, how many guys out of you are very much comfortable with the most basic rule that how switch learns the MAC address?
I know some basic.
Address resolution protocol.
Yeah, that is not required. Address resolution protocol will not get triggered, but what is the whole process behind the switch on learning the MAC address?
48 bits are the MAC address. 16s are reserved by the company, their product like Cisco, HP, right?
Okay. No, that is fine. I mean, what we are talking about is a step-by-step process on how switch finds out the MAC address.
ARP protocol.
No, not mandatory. It is going to be ARP.
So when the traffic towards to the switch, it store its MAC address into the TCAM.
Yeah, go on.
Yes. Yeah. So
Okay.
once the switch learns the MAC address, it will store in its TCAM files, and so when again switch is getting that traffic from the same link, it will just move forward to the associate like switch. So that's, I think, basic of MAC address.
Perfect. But before that, you need to understand, have you ever opened up the Ethernet frame? Have you ever seen the Ethernet frame?
So currently, like when I used to work on my CCNA, and then after I'm working as a like engineer as of now, sometimes I'm using Wireshark to like to know about where exactly my traffic flows. So during that time, like I sometimes open the Ethernet frame.
Okay. And what ideally you see in Ethernet frame? If we talk about, let's say, let me open up an Ethernet frame. Just anything would be, you see, this is the whole data of your Ethernet frame. This is what ideally is carried out in the Ethernet frame. Now, out of this, we are not bothered about this. We are not bothered about this. We are bothered about this aspect and this aspect. Source address and destination address. So what is this? What is address? Either it would be source MAC address or it would be destination MAC address.
Yes.
Now, how many of you remember the decapsulation process, what you have learned in CCNA? I'm going to talk in between. I'm going to talk a lot about CCNA because that's a base. If you are strong with that, the rest of the things are quite easy. Do you remember what is decapsulation process? It starts, if this is my OSI layer, this is my first layer, which is presentation, and last layer is physical. Decapsulation starts from top to bottom or bottom to top?
Bottom to top.
Bottom to top.
Rest of the guys all good with this? What is decapsulation process? So whenever it goes from physical towards presentation or above that, which would be application, then that is going to be your decapsulation process. And in decapsulation, what exactly would happen? So let's assume any kind of frame is originated by this PC and it reaches to the switch. What switch will do? Switch will start decapsulation process. So step number one is going to be frame reaches the switch. Step number two, decapsulation process will start. Once the decapsulation process starts, another important thing is done. Do you know what that is? I'll give you the hint. Just go through this. Is there anything else which switch will do?
Data.
No, it's a frame check sequence, FCR.
FCS, which is frame check sequence.
Frame check sequence.
So what switch will do? It will integrate. It will check the integrity of the frame. So FCS check will be done. And once FCS check is done, it will pick up the source MAC address. And where it will add it is added to CAM table. What is the full form of CAM?
Content
Containable is the
address
address
memory.
memory.
Yes, content address memory. So let's say I'm just assuming some numbers here, which is in Ethernet interface 0 by 0, 0 by 1. And here also it is 0 by 0. So this is, we are talking about a CAM or MAC address table of this machine, and it receives the piece, it receives a frame from PC1. So let's assume its MAC address is A and PC2's MAC address is B. Now what it found out, that source MAC address, which is A. So A is being learned on what interface? 0 by
0.
0.
0.
Right? The second thing what it will learn. And now, if you remember, we will be configuring every single port with VLANs. It will also find out that via which VLAN I'm learning it. So let's say I've not configured, initially I've not configured anything. And if that is the case, what is a VLAN in which all the interfaces will exist?
VLAN
What
number
is-
1.
Or default VLAN. Everyone is aware about default
Yes.
VLAN?
Mhm.
Yes.
So it is going to be, it will say that I am learning this in VLAN 1. It
One.
will create this entry. It will create this entry for first time. Okay. Everyone clear till now?
Yes, sir.
And once
Yes.
this process is done, it will check for destination MAC address. Where it will check for destination MAC address? In the same table. Do we have destination MAC address present in the table at this moment?
No.
So if it is not present, what it will do?
It will broadcast to all the switches.
It will basically send the data to all the ports. In this case, only one port,
Okay.
except where it has received it.
Every ports have different MAC addresses, right?
Yes.
Okay.
So what it will do, any frame received from PC1 initially would be landing on switch 1. And if it doesn't know the MAC address, what it will do, it will forward it towards other switch via broadcast. Everyone clear about this process, how exactly it would work?
Yes, sir.
Now, I'll repeat the process on switch 2. Same thing will happen. Instead of frame reaches the switch 1, now it will reach to switch 2. Step number 1, frame is received. Step number 2, what will happen? Decap process. Step number 3, FCS.
Yes.
Now it will check for source MAC. Is source MAC present? So what it will do? PC8 source MAC. From where switch 2 is learning it?
0/1.
0/1. So let's say I'll assume here to be the CAM table. Now what switch 2 will say? If it wants to reach MAC address A, it has to go on what port? 0/1. And it has learned via which VLAN? As of now, I am considering I have not done any kind of configurations. So it would be part of default
VLAN 1.
VLAN. Yes,
Mm.
which is VLAN 1. Everyone clear till now?
Yes.
Perfect. Now what switch 2 will do? Step number 5, check the destination MAC. If the destination MAC is not present into the switch 2 table, which ideally it is not, it will just broadcast it again to all of the ports. This is how a frame originated from PC1 will be reaching to PC2. Any doubts till now?
No.
Can I ask one question, sir?
Go on.
Okay, so just one thing regarding the FCS check. If I am not wrong, in FCS check is also checking is MTU size of the data. Is that right?
Yes.
Okay, so once if it reaches to maximum MTU size of 1500 bytes, it will like drop the frame.
If it is, yeah. So if ideally, if you are not capable to handle that much amount of traffic on that interface, it will drop it.
Mhm. Okay, thank
We
you.
will be talking about MTUs later on.
Mhm. Thank you.
Go on. Any other doubts? Perfect. Now we have spoke a lot, and there are two important another aspects which I've seen in my 10 or 12 years of career that maximum people are not clear about. Types of ports in switches. Ideally, when I say types of ports, it means either it can be an access port or it would be a trunk port. Anyone knows what is access port?
Port which carry a single VLAN.
Yeah, I was expecting this answer. I was literally expecting this answer.
Or you can say untagged VLAN.
Okay, so ideally, access port from a switch perspective is where you carry untagged data. It means no tagging of VLAN is done in access port. So where ideally you would configure an access port?
With the end user?
Last mile devices like on access switches
End host.
and also.
And host,
In
end
simple
user.
word, it is end host or end user. So maybe
Mhm.
PC. Tell me, towards firewall, will you configure access port or trunk port? General scenario, don't give me the exceptions.
Access.
Run port?
Trunk also.
Not mandatory. What if your firewall is acting as an L3?
Mhm.
You would configure it as an access or trunk.
Access.
Access.
What about router?
It would be trunk port for the router.
It's also access.
Access.
No, no, I think it's trunk port because we generally create VLANs like on router.
Okay, so again, case to case basis, not mandatory, but 70 to 80% it is going to be access. You don't need to have a trunk port if you have a router on the other side. There would be an exceptions totally depending on where are you working. Okay,
Mhm.
you can configure access as well as trunk. We are talking about the generic ideas. Now, let me give you a brief about why we should have trunk versus we should have access port. Maybe let's say this is a router and this is a switch. Below switch, you have PCs, 2, 3, 4. They are part of and they are connected to internet. Maybe let's say this is a part of subnet 10.1.1.0, 10.1.2.0, 10.1.3.0/24, and 10.1.4.0/24. Now, if this is the case, you tell me on router, will you configure on switch, the interface facing towards router, will you configure it as a trunk or access?
Since they are in a single VLAN, I think access would be work fine.
Okay, this is where the confusion lies. Do you see subnets
Yes.
4 different subnets.
Yes.
So if subnets are different, can you put different subnets into same VLAN?
No.
Maybe
No.
I configure
no.
here VLAN 10.
No,
I
no.
configure here VLAN 20. I
No.
configure here VLAN 30. And I configure here VLAN 40. Now you tell me if this is your L2 switch and default gateway for all these machines are this router, will you configure this port as a trunk port or access port?
Trunk
It will be trunk.
It will be trunk.
port.
Whereas here you will do a configurations of router on a
Stick.
stick. Clear why you will use trunk in this scenario?
Because different subnets. If it's same subnet, then we use access port.
If all the machines are
Same.
part of same subnet, maybe 10.1.1.0, and all these are part of same VLANs, maybe VLAN 10, then what you will configure here is access. Understood? It is case to case basis with respect to routers and firewalls or any other maybe access points, wireless controllers, IPS, IDS, whatever technology we are talking about across the different domains. It totally depends on case to case basis where with respect to routers and firewalls, whether you will configure it as access port or whether you will configure it as trunk port. Is this clear?
Yes. Sir.
Any doubts?
No.
Good.
No.
Now, the most important thing what you have to keep in mind is whenever anyone is asking you for access port, the first thing what you have to talk is that they don't carry any tags. There is no tagging on access port. Okay?
Yes.
Clear?
If there is tagging.
I am coming to trunk port now.
Oh, okay, sorry.
Now, let's say another scenario. I have these 2 switches. And I have different machines connected to it. Six. So let's say this is a part of VLAN 10, 20, 30. Here also it is 10, 20, 30. Now, PC1 wants to talk to PC4. PC2 wants to talk to PC5 and PC3 wants to talk to PC6. All are carrying different VLANs, correct? How does, let's assume we initiate a traffic from PC1. Switch 1 receives it. Switch 1 decides that it needs to forward it towards switch 2. But and then switch 2 ideally would forward it towards switch PC4. But how would you segregate the VLAN here? Though you have configured the VLANs on local to the switches, how switch 2 would come to know that this data originated by PC1 is coming from what VLAN? Any scope is there?
Configured on a.
No, we are not talking. Let's say trunk as a concept doesn't exist. Is there any way we can have this segregation?
To add it on a ports?
So by adding a VLAN ID on Ethernet frames, which usually trunks do.
Which usually trunks do. Now, if before assume this was a situation that trunk as a technology did not exist, there was no way that switch 2 or in this topology of our switch 2 would come to know that data is coming from what VLAN. So alternative to that was you had to add multiple connections. Maybe one for VLAN 10, one for VLAN 20, one for VLAN 30. That's how it will switch. One will receive the traffic and it will forward towards switch 2 and switch 2 will forward towards PC. Same thing for 20 and 30. Now, consider you have 20 VLANs. You would end up wasting 20 ports, 20 cables, and lot of mess would be created. Because you will be adding a lot of connections between the two switches, which ideally is not a feasible solution from a scalability perspective. That's where trunk concept was introduced. Trunk is nothing but a capability to add tag to the Ethernet frame. So what is that tag? That tag is nothing but your VLAN number. So this VLAN number will be added in the Ethernet frame. If I just open up the Ethernet frame one more time, do you see any options over here to add the tags? Anyone?
No. Yeah, let's start.
In the Ethernet frame format, there is no option by default to add a tag. That's where the trunk was introduced to add the tags. So what will happen in this case? Switch 1, switch 2. This is part of 10, 20, 10, and 20. So what will happen? Whenever machine is sending a data destined or to PC3, so let's say I'll assume the IP addresses to simplify the things. IP address of this machine is 10.1.1.1/24 and IP address of PC3 is 10.1.1.3/24. So let's say 10.1.1.1 is sending a data to 10.1.1.3. When that data is received on switch 1, switch 1 will do its function what we just discussed earlier, and it will find out that I am learning this specific MAC address, whatever is the MAC address of this, maybe 3333, let's say. So 3333 MAC is being learned on the trunk interface. And if that is happening, what it will do? In the Ethernet frame, it will basically fit a tag, and under this, it will fit up a value which is VLAN 10. So what will happen? There are rest of the details which I'll be coming up probably tomorrow. That whenever data is received on switch 1, switch 2 will ideally add a tag of VLAN 10 because it has received the data from VLAN 10. And it will forward this specific Ethernet frame towards switch 2. What switch 2 will do? It will open up the tag and it will find out, okay, I am getting this data in VLAN 10. I only have to check on what interface I am learning the MAC address of 3333, and it will forward a frame towards that. This is a basic difference between tagging and untagging, or trunk port and access port. Trunk port in simple words is always do the tagging. Access port is always about never do the tagging. Is this clear?
Yeah.
Yes.
Yes, sir.
Now, couple of questions as we are 5 minutes left.
Is there, is
Go
there
on.
anything like instead of rubbing this old notepad, can we save this notepad for everyone for a reference as a notes?
To be honest, I never give the notes.
Okay.
Why? There is a reason behind it. If I start giving the notes, you won't go through the videos. And if you won't go through the videos, there is a probability that you may miss whatever verbals we have done, or whatever maybe any brainstorming we have done, or any questions, any doubt someone had asked. You're not the first one to ask me the specific thing with respect to notes. I can give you the briefs, or you can just snip it whenever you are going through the videos for an easy understanding. But I want everyone to go through the videos thoroughly. That will help you to build your concepts. Last minute revisions, what we used to do in our engineering, is not going to be helpful if you want to make a career in networks.
Okay. Now, I mean, like the reason I ask you, because like there is no option we can download the video, and this video plus last only for 1 year, and after 1 year we don't have access. So that's why I was thinking, no.
I'll try to make up
grab-
something. To be honest, it consumes a lot of time to create on this data, but maybe some easier aspects I'll try to pass on.
Okay.
Okay.
Cool.
Now, if again this is a machine, let's say PC1. Now these are questionnaires what you have to answer. Okay. What will I configure here? Would it be access or would it be trunk?
Access.
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 What would be I would be configuring here?
Access.
Access.
What I'll configure here?
Trunk.
Access.
Access is only
This is where your brain is trained that you always think that between two switches always trunk. No, that's not a mandatory requirement. It totally depends on case to case basis. So look at the diagram. Let's say I will consider this as a part of VLAN 10. Let's assume this is a part of VLAN 10 and this is also part of VLAN 10. Just look at the diagram or look at the topology and tell me, do you really need to have access between two switches?
Is only one PC on both sides,
Yes.
right?
So
I don't think so
this is where I
yeah.
want you guys to rewire your brain on how you have learned the things that
We don't
between the
need-
switches, you need to have trunks configured. No, that's not mandate.
Yeah.
In this case, what do you think? Would you configure access or would you configure trunk?
I would say access.
should be
Access,
good.
not access.
Access or trunk? I mean, one or the other, doesn't matter.
Access.
Access.
You need to have this clarity that totally depends on the diagram, how things work. Okay?
If it's 10 PC on both sides, then we go for trunk.
Yes. Now, let me give you something interesting scenario. This is one of my interview question, what I always ask. PC2. Let's say IP address here is 10.1.1.1/24. IP address here is 10.1.1.2/24. Here everywhere it is access, no trunk. But there is a tweak. Switch 1, this is a part of VLAN 10. This is a part of VLAN 20. Switch 2 is a part of VLAN 20, and here it is a part of VLAN 20. Will these guys talk to each other, PC1 and PC2?
No.
No, you need a trunk here.
Yeah, I knew. You're forgetting most important line. What did I told you with access? What is the most important thing that should strike your mind?
Without tagging, I mean, if it's VLAN 10 and the switch 2 is VLAN 20, right? And if access point, they will not talk to each other.
They will talk, because once the switch 2 is untagged, the frame will automatically be sent to the untagged VLAN. In this case, it's going to be VLAN 20.
How many of you are clear? Okay, let me explain. That is correct. They will talk to each other.
Okay, explain, sir, one more time.
They won't add any tag since they are access ports.
What did I say with respect to access? No tags, correct? So when I say no tags, let's say this machine is generating a frame and it reaches to the switch, correct? Do the
Okay.
reverse engineering for the whole process. Decapsulation starts, FCS is checked, source MAC address is checked, destination MAC address is checked. Now destination MAC address, let's assume that it is learning the destination MAC address of PC2, maybe B, and PC1 is A. Now what switch one will say? If I want to go to if I want to go to MAC address B, what is the port I have to use? Maybe this is 0x1, for example, and this is 0x0. What is the port I have to use? 0x1, correct?
Yes.
And you are learning it in which VLAN?
10.
10. So what will happen? It will just forward the frame, whatever it has received from switch 1 here to switch 2 without any tag. Correct?
Yes.
Waibo, following me?
Yep. I'm confused. Like, if like PC1, right? If PC1 is sending any data packet to switch 1, VLAN 10, right?
Mhm.
How would the VLAN 10 know, like, this message will go to VLAN 20?
They will
That's
never know. That is the whole
this-
purpose of having the no tags.
Okay. But
No
how?
tags, no tags in simple words means no tags, correct?
Okay,
Yes.
right. Yeah, exactly.
Let's break the whole process. PC1 don't know what is the MAC address of PC2, correct?
Okay.
It will generate a first ARP. Let's assume this. ARP will have a source MAC address of
Test.
A.
Yeah.
No, source MAC. Destination MAC address, let's say, is a broadcast, which is F.
Broadcast. Yeah.
Correct? This frame reaches to switch 1. What switch 1 does? Remember the process. I am pasting the process in the chat for you to go through it. I mean, not only to you. Where is the chat option? Give me. Go through this. What it will do? It will pick up the source MAC address, add it to its CAM table. So let's say this is a CAM table of switch 1. So it says if it wants to go to A, it is learning it from VLAN 10 on 0x0. It will check the destination MAC address. It will find out that I don't know where is the destination MAC address is connected. It will do broadcast because we are talking about VLANs. Any broadcast received from VLAN 10 would ideally only be forwarded in VLAN 10. Correct?
Yep.
So the broadcast what we have received on 0x0 will be landing on 0x1, correct?
Yes, correct.
And then it will traverse till here.
Okay, yeah, that's correct.
Now there is no tag present. Now,
Okay.
if there is no tag present, would switch to come to know that the data received is from VLAN 10 or VLAN 20. Because it is entering onto the port, which is configured with access VLAN 20, it will repeat the whole process, what I have just pasted.
Oh, okay. Now I got it. Okay.
Now
Then it's gonna repeat the same process.
Repeat the same process, and what it will say, if it wants to reach to MAC address A, it is learning it from VLAN 20 on interface Ethernet 0x1, and it will again forward it. So what it will do? Any broadcast received on VLAN 20 would be landing to the other ports configured on VLAN 20.
Got it. Now I got it. Okay.
Now it will go to PC2. Now we are talking about first broadcast stream, but that's how the end-to-end MAC learning will happen. And if the MAC learnings are happening, because there are no tags, the data will communicate between the two. Is this good?
Yep. Perfectly fine.
Any other doubts?
No.
Perfect. If no, we'll be continuing tomorrow same time. And we will be talking about the trunking types of trunking protocols and further things, but it is going to be all packet walks. Wherever it is possible, we are going to talk about all the packet walks and everything from the scratch, which eventually will help you to think in the most basic way.
Okay. And tomorrow class is gonna be more than 2 hours, right?
Yeah, tomorrow it is going to be 1 hour, I believe. I need to confirm that from Goro.
Okay.
I'm fine
And
even
plus
for 2 hours.
and plus the lab, please, if you don't mind, for the lab access.
I will be asking.
Sir, hello.
Go on.
Sir, can I ask about the broadcast domain?
Go on. What is your doubt?
Okay, sir, if it is on server client architecture. Okay,
Help
I
me.
have
Mhm.
5 VLANs.
Okay. Should I
Each-
consider one switch?
Yes, okay. I have 5 VLAN. Each VLAN have 5 devices.
Okay. 10, 20, 30, 40, 50. Correct?
Okay.
And maybe 5 devices. It's going to be huge. Okay. 25 devices in total.
Okay. That is connected to one. These devices are communicating to one server having VLAN 60.
Let's say this is a server.
Yes.
Server. And then maybe I will just draw one from every VLAN.
Okay.
10,
So,
20, 30, 40, 50. Yeah, go on.
okay. Sir, VLAN 10 have one broadcast domain having 5 devices. Okay.
That is fine.
Okay. 50 have a 5.
Okay.
Total 25. Then
Devices.
what about the VLAN 60?
What do you mean by what about VLAN 60? It is only
This-
having one server.
Yes, one server, but the traffic is very high, right? Because these 25 devices are connecting to this server.
Okay.
Is that any problem?
Totally depends. Totally depends. So basically, you're talking about the bandwidth consumption, correct?
Yes.
Okay. Now things are clear. So let's say all these 25 devices are of 1 gig, 1 gig port,
Okay, let's consider 1 gig,
and here also it is 1 gig,
10 gig.
10 gig. So ideally, there is a bandwidth ratio. There is a formula what you have to follow. The downstream would ideally be lesser as compared to the upstream. Getting my point? So ideally, minimum you need to have here is 1:1 ratio, which is ideally you need to have a 25 gig port in used, or considering that all the clients will not be talking to the server at same point of time, you need to use 20 gigs here between switch one and the server.
Basically, server needs a high bandwidth internet.
Not internet, this is just a plain communication without any
Plain
internet.
communication,
But
yes.
Sir, let's consider this is one CCTV server. Okay, these are 5 are on 5 building.
okay, these are spread across 5 building, not to the same same switch.
No, let's consider that one. Okay.
Mhm.
And then the VLAN 10 between that broadcast domain we have consumption is 1 gig. 1 gig. Okay, VLAN 10. Hello.
Go on. I can hear you.
Okay, so what about this line VLAN 60?
Okay, so it totally depends on what data you are what data is traversing across this specific link. How much data these 25 devices are sending? Are they sending the device data at same point of time or different point of time? If it is CCTV, all 25 devices are CCTVs.
Yes.
It means they are constantly sending the feeds towards the server.
Yes.
Exactly. Yeah.
So if the server is constantly receiving the feeds, there is a high probability. And again, CCTVs work with 2 different options. One is a multicast and one is a unicast. What is the scenario in this case? Is this communication unicast or multicast?
So actually CCTVs are unique camera to server unicast, right? If it is not monitoring, it is unicast, right?
I am not a CCTV expert.
Okay, sir. Actually, if I am okay, VLAN 10, I will put one PC here. I will take the 5 cameras, I will use the one multicast IP address of 5 cameras, and I will use the VLAN 10 area.
So in simple words, it is a unicast communication. That's
Yes,
what you're
yes.
trying to say. If it is,
Yes.
even if it is unicast, it totally depends on how much feed they are sending, correct?
Yes.
Constantly how much they are sending. Let's say if it is sending 100 kbps, 100 kbps into 25. Do this calculation. Is it going about 10 gig?
Yes. Okay. 25 into okay. Okay.
So
I got
you need to understand the basics on how much feed is actually being sent. Are you facing any kind of problems with this? Are you saying that your server is not able to receive the data? Or is it only out of curiosity you are asking whether this is a speculative answer? This is a subjective case to case basis. With 10 gig, maybe there is no issue. In future, you
And
may have to add if
might be, I think he's trying to explain like his server is slow because the
We-
CCTV is sending a live data packet.
we need to know what exactly is the problem.
No, sir. I am asking if you ask how the VLAN 60 is the broadcast domain, how many devices? Only one device, right? If these 25 devices are communicating to server also, there is one device only, the VLAN 60, right?
Okay. Yeah, that
It
is
the-
fine. See, if you have spread it across the building, you are saying there are 5 buildings, right?
Okay.
We need to know the whole infrastructure. The broadcast domains are always local to the switches. There would be a L3 broadcast in between, correct?
Yes.
So if there is an L3, then the broadcast domain, what you have in building 1 will not impact anything in building 5.
No. Okay.
So it is not about a broadcast domain here, or it is not about a total number of devices. Even if I connect 100 cameras, and if they are hardly consuming 10 kbps, my 10 gig is more than enough.
Okay.
So broadcast domain is always local to that LAN domain. In simple words, let's say this is a router connected to a switch here. And below here, you have humongous number of devices. Doesn't matter how many, maybe 100. Okay, multiple switches. And here you have another switch, which is switch 2. And here you have 200 devices. This is one broadcast domain. And this is another broadcast domain, which is getting segregated by your router. That is the job of a router, L3 device. Hope you have in your CCNA, you have gone through that layer 3, we put a boundary on the broadcast domain. So any broadcast packet or any broadcast frame originated from this specific domain will maximum come to this specific interface and it will get dropped. It will never traverse across another link. That is the job of router, not to broadcast the frames from or the packets from one interface to another interface.
Yeah.
Okay, sir. I got you.
So 100 devices in one building is different domain, and switch
Totally
to
depends on what is your topology. If there is no L3 in between, it is going to be same broadcast domain, then it will affect. But if there is any L3 in between, then situation is totally different.
Okay, but might be is like you say, the CCTV camera definitely is in the same domain.
No, not compulsory, right? You won't be spreading across your L2 domain in 5 buildings. That is not possible. There would be L3 devices in between.
L3 device, exactly. It won't be possible. Okay.
Go on, any other doubts?
No.
No, sir. Nothing for today.
Okay, see you tomorrow, same time.
Same time. Mhm.
Thank you,
Same
sir.
time.
Bye-bye.
Thank you. Thanks for today. Thank you.
Yeah.
Thank you,
Thank you,
sir.
sir.
Thank you.